Hey everyone, now we're just going to do a ton of limits and
For fun!
hope we can make it through it. So let's do limit of x approaches infinity of sine of x. So does this have a value? Well, draw a picture. Ready? Okay, so as we get close to infinity, sine of x doesn't want to change at all because sine of x is annoying. So, well, it's not, but if we choose infinity to be here, then we get a value. If we choose infinity to be here, we get another value. And infinity doesn't get to choose a value. It keeps going on forever. So even if we wanted infinity to end here, it could still go out here. So this guy doesn't have just one value, so it doesn't exist. Okay, sine of x over x. So we'd think it's the same thing with sine of x over x.
But now it's as x approaches infinity.
Yes. And so, well, sine of x basically acts like either a -1 or 1 or something in between as x approaches infinity. And x, well, x approaches as x, so it gets bigger and bigger and bigger.
A huge number.
But sine of x doesn't get bigger. So sine of x is some number, okay? Whatever number, we don't really care.
Some small number.
Yeah, well, not small, but it's not big. And it's some small number, or, okay, sorry. It's some number that we understand. So it's between -1 and 1 over something really huge. So it's like the difference, what's the difference between, well,
$1 and a million.
$1 and $2 versus $1 million, okay? Neither one matters, okay? So this thing approaches something over something really big, and that's basically 0. Okay?
Good.
And I did that. Okay, these are all infinities. Okay.
Tan of 2x over 2x.
Over x.
Over x.
Okay. So we're taking a limit again, and this one's really gross. So what do we do?
You left extra space, I can see.
Yeah, so we need to remember when we're splitting up products of limits, which is what we're going to do in this case, we cannot split up products of zeros whenever there's a 1 over 0 somewhere else, or whenever there's an infinity, okay? We cannot pull out infinities whenever there's going to be a 0 or something like that. And so we just want to stay away from things that diverge or are infinite, okay? So basically, you only want to pull out stuff that evaluate as limits of constants, okay? So like limit as x approaches 1 of x, we're allowed to pull this guy out because it's a constant after we evaluate it. Same thing with the limit as x approaches 0 of sine of x over x, because this approaches 1. So we're allowed to pull that out. Okay? So first, well, we need to figure out what we can pull out. Can we pull out x?
Can we pull out x?
No, we
No.
can't. Okay. The reason is because it's a 0. We can't pull out zeros,
Oh yeah, you can't pull out zeros.
right? That's like dividing by 0. That's breaking math. So,
Breaking Bad. Anyways,
that didn't make sense.
it's a TV show.
I know it's the fact that you say that makes you sound really ignorant or out of it, but that happens. So we know that tan of 2x is sine of 2x over cosine of 2x, and that's just the definition. Okay, so now what can we pull out?
We can pull out cosine 2x because that evaluated at 0 is 1.
Yes.
So, but you want to pull out 1 over cosine 2x.
So we want to pull out anything that's finite. So we can pull out cosine of 2x. And so now we get the limit as x approaches 0 of cosine of 2x. Oop, there's a 1 over. And times the limit as x approaches 0 of sine of 2x. I don't know why I keep making bars. Over x. Okay.
Yay.
So this guy, we know 1 over cosine of, well, plug in 0. 1 over cosine of 0 is 1 over 1, which is 1. So we can 1 times this thing is just itself. And then now we have this thing, which we don't really understand at all. So by some magic or calculus or whatever you want to call it, we see that we want to make it so that we get something that is sine x over x, because we don't understand sine 2x over x.
We understand sine of x over x because we know that's 1. We've memorized that.
So we let 2x to equal u, so that we can just get one variable in the sine. Okay? And so we rearrange this equation, we get x equals u over 2, and then we plug in u over 2 everywhere.
That would see an x.
So we get limit as
U approaches
u over 2 approaches 0
yay
times sine of u over
u over 2.
u over 2. Okay, we treat this arrow like it's an equal sign, so it's really the limit of u approaches 0. Okay.
Because u 2 approaches 0 is like
Yeah. So we just multiply that over basically. And we know that u over something over 1/2 is 2 times that. Okay. And so we also know that we can pull scalars or numbers outside the limits. So let's do that.
2
2 times the limit of u approaches
0
0, remember, multiplied the 2 over, of sine of u over u. Okay, well, we know this chunk is 1, and that's 2, so it's 2 times 1 equals 2.
The limit is 2.
Yep. Okay.
Now, next problem. 4x squared plus 5x plus 8 divided by x squared plus sine x of x. And we're evaluating the limit as x approaches infinity.
Thank you for the commentary.
Couldn't resist.
So, how do we do this thing? Well, we just close our eyes and hope that it works out. But, okay, so this thing is really gross looking, right? But
Actually, it's not too bad.
we just have to remember that as everything gets really big, this guy doesn't get really big, and well, 8 might look big, but it's not. So, 1,000,000, 8 has nothing on 1,000,000. Neither does sine. So, we just pretend this goes away. And now we can think of x squared plus 5x. Okay, 4x squared plus 5x. Which one grows bigger faster? X squared grows bigger faster. Is it by enough that we can ignore this guy? Yes. And why is that true? Well, we can think about it a little bit. And, I mean, normally you don't have to do this out mathematically, but if you want, you can convince yourself of this being true. Okay? And so
On a test, you can just assume
that x grows way
x
larger.
squared goes way bigger than
X as x approaches infinity. Okay? As x approaches 0, x squared grows faster than x. So you have to be careful. But we can write this. So we're ignoring this guy, ignoring those guys, this guy. So it's 4x squared plus 5x all over x squared. Okay? We can factor out an x from the top. Pretend we're not factoring out from the bottom. Okay? Just for purpose of demonstration.
Usually, you just skip to the last step.
Okay. Now, this 5 doesn't mean anything compared to this x.
Where did the x squared on the bottom go? Thank you.
So, now we can ignore this 5. And now we get 4x squared over x squared. And if we divide that through, it equals 4.
The limit is equal to 4.
So, if you think about those rules that they give you for limits, they're all grounded in some type of reality. They just tell you to take the highest power, and that makes sense now, because everything else is nothing
Meaningless.
compared to it. As we approach infinity, of course. Okay, when we're not approaching infinity, they do have meaning. Okay, So now let's do limit of x approaches 0 of e to the x over x squared. So let's plug it in. 0, what's e to the 0?
1.
So e to the 0 over, what's,
0.
okay, 0 squared. So it's over 0. So we're not allowed to divide by 0. So instead of dividing by 0, since this is approaching 0, it's something small. So what's something normally sized divided by something small?
Infinity.
Thank you. I was supposed to explain that one, but
Sorry.
it's like how many molecules are in your body. Okay, your body is normally sized to you. Molecules are really tiny, and there's just way too many of them to count. So we have that approach.
A better way to convince yourself is to divide 1 by a very small number, and then divide 1 by a very, very small number, and you'll find what we mean.
But is it a positive or negative infinity? Or neither? Remember, if it approaches positive infinity on one side and negative infinity on the other, then it doesn't converge. But we know because this thing is always positive.
Why?
So,
X squared is always positive.
Yes. So whenever we use small quantities on the bottom or big quantities on the top, we always need to put a sign.
So positives plus, and the top is just 1.
Yeah.
Cool.
So whenever we have infinities, track back to check all your signs. If you don't have an infinity there, we don't care about the signs. But if we do, then just keep the sign. And this one's approaches infinity.